All right. Good morning, Trisha, Michael, John, Christian, and Prince. So, yeah, happy ano na ba ngayon? Thursday, almost the weekend no ulit. So, let me see. Couple of words about the problem set. How did you find it, guys? Masyado bang mahirap, mahaba, or what? I want to get your feedback para naman pag isusulat ko yung susunod na problem set, I can make appropriate adjustments for you guys. I'm still grading it. Natapos ko ng grade doon yung mga early birds. So, those who submitted siguro before 5 p.m. yesterday, na-checkan ko na yung lahat ng kanilang items na sinubmit. But those who submitted near the deadline, medyo tumambak na sila uli. I'm still uh, I'm still 6 papers away to finish PS 1.1. Tapos susunod ko na yung 1.2 and so on. It might take me until the weekend to finish it. I have something to kailangan ko mag-relax mamayang gabi, so I'll be out. Baka hindi ako makapag-grade and I'll need to finish a proposal para sa uh, or kailangan ko mag-propose some project para sa IMSP. Deadline is tomorrow. I'm gonna do that later tonight. So, medyo hectic na yung schedule and I need to write a problem set for 175 tomorrow. So expect the results of the problem set perhaps over the weekend or probably on Monday or Tuesday at the latest. Pero I'll keep on grading it every time I get a chance. Okay. Now, ano nga ba yung mga common concerns doon? Let's see. I can't remember very big issues. So, by the way, siguro dun sa true or false, I look at the item analysis for the true or false part. And it seems that almost all, actually parang lahat ng items ay merong discrimination index more than 0.5. So that means the question differentiated those, I mean, each question differentiated to some good extent yung mga nag-perform ng maganda dun sa problem na yon and hindi. So some of them might be tricky. So merong iba na sumabit in some particular questions, but I reopened the actually I allowed the display of the correct answers now. So na-try nyo bang balikan? So if you go to problem to your work on PS 1.5, I hope you can now see the, of course, alam niyo na yung correct answer kasi true or false lang naman siya. Pero meron ako nilagay din na explanation why, kung bakit siya true or bakit siya false. So you can go back to that and look at those my explanation para dun sa mga items na na-miss nyo. Alright? Kasi parang lahat ng item, merong mga sumabit. So around, I think 90% or 80% at most yung tumatama dun sa bawat item. So yeah, take a look at it and let me know if you have some questions about that. My only request is do not post it right now because there are some students with valid excuses na hindi pa nakakapagpasa ng problem set. So you can download it, keep it to yourself. Huwag niyo munang ilabas sa social media nyo or to your Facebook group or whatever because some of your classmates might be still working on it. All right? Because kung mangyari yon, kailangan ko magbigay ng panibagong set of questions. And kung nasimulan na nilang sagutan yung previous questions, mababaliwala yung effort nila because I will be forced to write a new set of questions. All right? So I think that's it. Anong reactions niyo sa problem set? Wala? Ayaw niyo magsalita? But don't worry, this is a safe space. So if you want to criticize the problem set for its length or difficulty, it's fine with me. All right? Para magawa ko lang yung adjustments in the next problem set. Sige, David.
Sir, ang sinagutan ko is yung 1.2 po. And I think an entire day simula nung isang araw ako nag-start dun, tapos para mali pala yung direction ng proof ko. Tapos took me more than 10 hours to realize that. Tapos ayun, I think tahanak pa naman.
All right. Yeah, that's good. And that's the point of learning. You're not expected to sit down and say do it in 20 or 30 minutes or do it in one sitting. So, ganun talaga yon. Tapos, ang learning, hindi siya linear. So, yung ating, yung ating yung ating academic life, especially as students, hindi yan isang straight line. It's more of a curvy line na maraming wiggles along the way. And we need to navigate dun sa mga roadblocks, sa mga wiggles na yon. So, yeah, don't feel bad if your first attempt was bad, or if it took you too long to write the first attempt, and then later you realize that there is something wrong. Actually, realizing that something is wrong in your work on your own is really a good hallmark of learning. All right, I guess it's for me. I appreciate it more than somebody who will submit it perfect at the first time. Though I don't want to demerit them or to play down the excellent thing that they did, pero mas na-appreciate ko yung ganung mga kwento na yung una mong attempt mali, pero na-realize mo sa gitna, may mali sa ginawa ko. Kasi yun yung isa sa mga pinakamahirap gawin. Yung kumbinsihin yung mga sarili natin na mali yung ginawa natin at the start. And adjust, and then learn from our mistakes, and hopefully improve our outputs. All right. And that brings me to this, this is a nice segue. This brings me to this nice picture over here. Instead na meme, ito na lang yung pinost ko ngayon. And I am happy that at least there's another person in the class who's appreciating yung mga memes. Nakita ko dun sa sagot dun sa 1.1.c. All right, so problem set. Yeah, this is one of my most favorite quotes of all time. And una ko to nakita sa isang episode ng 24. Naabutan niyo pa ba yung 24? It's a series by Kiefer Sutherland. So talagang nagpupuyat ako or binibinge watch ko yan yung 24 na yan. And there's one speech there where the president said, in every democracy, the people get the leaders they deserve. And that quote can be traced back to Joseph de Maistre. Sorry, hindi ko ma-pronounce ng tama yung kanyang French na apelido, right? But he said that every nation gets the government it deserves. So um, I think this is very apt at this particular point because sometimes we are always blinded by either fanaticism or blind loyalty, or sometimes it's just our pride that dahil sumuporta ka sa isang particular person, then by hook or by crook, you will stand for him or her, even though there's something wrong, or you are going against your principles kasi ma-pride ka, papangatawan mo siya hanggang sa dulo. And that's something that is very hard to admit. Admitting something is wrong and adjusting due to it, all right, and making yourself better. So personally, the news lately is very depressing. You see people fighting each other. Okay lang naman na makipag-argue as long as you're arguing that you're using valid arguments. Ika nga sa Math 101, Pero sometimes you see na wala ng logic o wala ng solid foundations yung mga pinagsasabi nila. It's as if it's easier to believe a random picture on a desk with a candidate's name and some pile of money beside it, uh, and use that as a proof for electioneering or something, right? Rather than watching a video of these traditional politicians handing out money to people, even if it's election time or it's prohibited under the law, and it's as if those big guys can get away with it, right? So it's as if that yung mga bagay na ginagawa nila in broad daylight ay napapalampas, all right? And that's one thing. If we will not, as a collective people, make them accountable for these actions, then we deserve the kind of leaders that we get. All right, and that's unfortunate. Pero medyo may pagka-vindictive kasi ako. So if in May 9 we elect the same brand of leaders again and again, all right, then we deserve what we will get. We deserve to be left as a third world country. All right. So hopefully the new generation, you guys will step up and be the change that our generation or the generation before us were never aware. So it's up to you guys. All right. Okay, so enough of that. Kailangan lang mag-vent out kasi medyo ano nga, medyo stressful. I mean, di naman stressful, depressing, medyo, pero I think the word is disappointing, all right? And I guess at the back of our mind, at the back of my mind, if good leaders will not get elected, then shame on us. All right. Okay. So anyway, so last time we were talking about baka ma ano na ako eh. Baka ma-censor na ako. So, but anyway, it's my freedom to speak up. All right. So going back to regular programming, okay. So last time we were talking about sequences, and then sinabi natin that the business of analysis is looking at the behavior in the long run. Ano yung nangyayari dun sa dulo ng listahan yung sequence? We look at the definition or how we operationalize yung sinasabi natin na ano yung limit as kung saan nagkukumpul-kumpulan yung mga elements o mga terms ng sequence dun sa dulo. All right? So we saw the definition, and then we look at several examples on how to use the definition to prove that the limit of a sequence is equal to a specific number. All right, and it's not an easy task. All right, because we need to deal with an arbitrary epsilon. As long as it's greater than 0, we need to find a corresponding natural number and so on. All right, medyo tedious yung definition. And it's even tedious to prove that a sequence will not be convergent. All right? Kasi nga, kailangan naman nating ipakita na may nag-exist na epsilon for which sa lahat ng capital N, the inequality involved in the definition will not hold. All right? But thankfully, mathematicians, in their ingenuity, discovered some theorems that will help us not only calculate limits, all right, pero para masabi na convergent o divergent yung mga komplikadong sequences by just breaking them down into several pieces or several smaller or simpler sequences na kaya nating ma-detect kung nag-exist yung limit nila or hindi. Yun yung mga algebraic theorems na nakita natin last time. All right? So parang parallel siya. So kung meron tayong algebraic axioms for the set of real numbers, so meron tayong algebraic theorems for sequences. So we did that last time. And then those theorems are familiar to you because you used them already in other courses, all right? Ngayon, titingnan natin naman yung order limit theorem. So meron tayong order axioms. Now, ano naman yung analog ng order axioms para sa set of real numbers dito para sa mga sequences, because sequences are just a special subset of the set of real numbers. Okay. Now, let's look at this, and then hopefully towards the end of the class, we'll be able to touch some of the big names or the big theorems in analysis. And you will see that some of these were already mentioned or alluded to in the previous chapter kasi itong mga theorems na to na may malalaking pangalan, sila ay equivalent sa completeness. All right? But first things first, let's establish the order limit theorems. So yung order limit theorem, sinasabi niya lamang yung behavior with respect to the less than or greater than relation ng limits ng sequences. All right? So our assumption in theorem 2.4 is that we do have two sequences, okay, sequence of ANs and sequence of BNs that are convergent to A and B respectively. So nag-start tayo sa dalawang convergent sequences. Now, what can we infer from these two convergent sequences? Now, we have three properties. Property number one, kapag ka lahat ng terms doon sa sequence ay non-negative, all right, then yung limit dapat ay non-negative. So it's impossible to get a sequence of non-negative real numbers that will converge to a negative number. All right? So dapat dun siya magko-converge. Non-negative pa rin yung limit nila. And then you can treat Part B as a corollary to that statement. Makikita natin sa proof later kung bakit siya directly nagka-follow sa Part A. But Part B is just saying na kapag hinilera mo lahat ng elements ni AN at lahat ng elements ni BN, yung corresponding elements ni AN ay less than or equal to dun sa corresponding element ni BN. So ibig sabihin si A1 ay less than or equal kay B1, si A2 less than or equal kay B2, and so on. At nangyayari to sa lahat ng terms ng sequence, then the limit of the sequence of ANs is less than or equal to sa sequence ng mga BNs. So imposible na maging mas malaki si A doon kay B. Alright? Kasi nga yung terms ng sequence na nagko-converge kay A ay laging mas maliit or equal dun sa mga terms ng sequence na nagko-converge kay B. Alright? And then lastly, okay, if your ANs are bounded above by a constant C, then it is guaranteed that the limit A of that sequence will not exceed C. All right? So kapag ka upper bound si C ng mga ANs, then si C ay kailangan mas malaki or equal dun sa limit nila. So hindi siya lumalampas. All right? Okay, so let's take a look at the proof. Okay. The first one, nilagay ko na siya dito kasi medyo computational yung proof. Kailangan ko ng specific epsilon. Kaya hindi ko na siya gagawin from scratch. Okay, but let's see. Let's look at the proof. Part A. This is done by contradiction. Okay, and here we will suppose that the limit is negative. All right, because in statement one, our assumption is that all the ANs are non-negative, and we are claiming that the limit is necessarily non-negative as well. So suppose ko yung kabaliktaran nun. Kunwari mali si theorem. So ibig sabihin, the limit is negative. Now, since A is the limit, then for remember the definition, kahit ano pang epsilon yung piliin ko, I can find a starting index such that after that starting index capital N, the distance between AN and A will be less than epsilon for whatever epsilon we choose. All right. But for this proof, I'm going to choose epsilon to be equal to negative A over 2. Because we are assuming by supposition that A is negative, then negative A over 2 would be positive. All right. And since it is positive, it is a valid choice for epsilon. Okay. So mag-hold yung definition, we can find a starting index capital N such that starting from that index, yung distance between A little n minus A or between A sub little n and A ay mas maliit sa negative A over 2. And that's perfectly fine so far. But if we dig deeper into this inequality, what do we get? Well, expand ko lang yung inequality na yan. This is a continued inequality. Elementary algebra tells us that tanggalin mo lang yung absolute value, tapos copyhin mo yung right side, tapos sa left side, magdagdag ka lang yung negation nung nandun sa kanan. So this will just be A over 2. All right? And then what I'll do is to add A to all sides. Now, I could have done a lot of things with this continued inequality, but since we're looking for a contradiction, my mind is telling me na hindi ko pa nagagamit yung assumption dun sa proof, right? The assumption is there for a reason. So I need to be able to use that assumption in order to get a contradiction. But what is our assumption? Our assumption is that all of the ANs are greater than or equal to 0. Mapa nasa unahan ng listahan o mapa nasa dulo ng listahan, lahat ng ANs ay dapat non-negative. And so we have a property for the ANs, so might as well look at how ANs will or what property of the ANs will be deduced from this continued inequality that we have. And that's easy to do. I'll just need to add A to all sides of this continued inequality, right? And if I do that, I'll get this guy. Okay? Tapos simplify mo yung kaliwa, we'll get 3 halves A. Simplify mo yung kanan, makakakuha tayo ng A over 2. All right? So let's try to see what we have gotten here. So we now know that A sub n will be less than A over 2. All right? But what do we know about A over 2? A over 2 will be negative, right? Kasi si A ay inassume natin na negative, divide mo yung negative by 2, the answer will still be negative. So now we know, or now we see, that A sub n are necessarily less than 0, but that is screaming a contradiction. Bakit siya contradiction? Assumption ng theorem ng lahat ng AN ay greater than or equal to 0. Okay? So this is a contradiction, all right, to our assumption. So our supposition is false. So that means A must be greater than or equal to 0. And so that establishes part A. Questions? I hope that's clear. Straightforward naman yung proof, no? Medyo amazing lang kung paano niya nasabi na piliin ko yung epsilon to be equal to negative a over 2. And perhaps that is a product of a preliminary analysis, all right? And I don't think this choice of epsilon is unique. You could have chosen some other epsilon. Let me see. Yeah, I think you could have easily chosen epsilon to be equal to a. Kasi kung pinili natin ang epsilon to be epsilon equals negative a. Kasi kung pinili ko siya as negative a, mag-appear na kagad dito yata ay 0. And choosing epsilon to be negative a is a natural choice. Bakit siya magiging natural choice? Kasi nga, nag-introduce ka ng supposition na si a ay less than 0. Alright? Tapos, definition ng limit lang yung pwede nating gamitin. As a definition ng limit, meron kang epsilon greater than 0. Now, you have a number which is assumed to be negative and you're looking for a contradiction from it. Alright? So, gamitin ko siya. So, gamitin ko si epsilon to be negative a. And I think the proof will go well if you do that. Kakaroon ba ng malaking problema? Baka pala magka-problema sa negative a. Okay lang pala. Maybe you can try that out. I don't see any problem for that proof unless mali yung mental arithmetic ko. All right? Okay, now let's look at part B. And I mentioned earlier, spoiler alert, that part B is sort of a corollary to part A. Kasi kung makikita nyo, all right, A sub n is less than or equal to B sub n, then I can form another sequence. I can form the sequence B sub n minus A sub n, right? So the sequence formed by taking the differences of corresponding terms in the respective sequences, all right? But if by assumption A sub n is less than or equal to B sub n, then all the members of the new sequence, yung mga bn minus an, would be greater than or equal to 0. All right? So I have now a sequence of non-negative terms, which should ring a bell. Kakaprove lang natin na kapag meron kang sequence, pag meron kang convergent sequence ng non-negative terms, then yung limit nila ay non-negative terms, ay non-negative din. All right? Now, in part B, dun sa assumption, nakabuo ako ng sequence na siya ay puro non-negative yung laman. So, pwede kong i-apply si part A. I can do that because I already proved part A. So, anong alam natin? Well, etong sequence na to ay magko-converge. Kasi sabi ng algebraic theorems natin, meron kang convergent sequence, yung sequence formed by their sums or differences ay convergent pa rin. So, ito ay convergent. And more than that, we know that Bn minus An will converge to the difference of the respective limits as well. All right? Tapos sinabi na natin sa part A, yung limit ng sequence of non-negative real numbers ay non-negative din. Yung Bn minus An magko-converge sa B minus A. So that means B minus A must be non-negative. And then a little algebraic manipulation will bring us to the conclusion that A is less than or equal to B. All right? So I saw several reactions earlier about nung nasa middle pa lang ako ng pag-explain ng proof ng part B. That's nice. Thank you. I appreciate your reactions. And I take that reaction as you already foresaw what is going to happen. All right? That's good. That's good. Thank you, guys. All right. And then, so that is essentially what this two-line proof is telling us. In-explain ko lang siya in details. All right. And then let's see part C. I think part C is also a corollary, but it's a corollary to part B. Okay? Okay. Maganda naman yung ginawa, yung trick sa part C. Kasi sa part C naman, kamukhang-kamukha siya ng part A, pero ang problema, yung bound ay hindi sequence. Alright? Kung alam natin to ay totoo as a sequence, yung AN ay mas maliit sa lahat ng BN, then sure tayo na totoo yung inequality na nandito. Alright? But what we know from part C is that AN is always less than or equal to C. And C is a constant. Okay? But remember that hindi pa pala natin na-prove, but I think it's easy to prove that a constant sequence is convergent. All right? Kung meron kang sequence na puro C yung laman, sure tayo magko-converge yun sa C. Ang epsilon mong pipiliin actually kahit anong capital N kasi yung difference ng lahat ng terms, okay? If you have AN minus C, okay, tapos yung mga AN mo ay equal kay C sa lahat, so 0. So ibig sabihin kahit anong epsilon ay mas malaki doon sa difference between the terms in your constant sequence and the actual limit, which is actually the constant term. All right? So ang gagawin ko sa part C, kahit ito lang yung assumption, si AN ay less than or equal kay C. So i-construct ko yung sequence, tawagin ko siyang sequence ng CN, all right, or sequence na CN, nang laman niya ay puro C. Okay? Tapos si A1, sure ako, mas maliit siya kay C by assumption, or it's less than or equal to C by assumption. So that means AN is less than or equal to C1. A1 is less than or equal to C1. Then A2 is less than or equal to C2, and so on. All right? So ibig sabihin, magkakaroon ako ng AN less than or equal to CN for all N in N. All right? Which is basically what we already considered in part B. Kapag meron kang sequence na lahat ng corresponding terms ay mas maliit sa terms ng isa pang sequence, then yung limit nung nasa kaliwa ay mas maliit sa limit nung nasa kanan. All right? Now, what's the limit of CNs? Again, the limit of CNs is C because it's a constant sequence. So therefore, the limit of AN, which is A, mas maliit siya kaysa kay C. All right? So kaya nga nag-follow lang siya directly from part B. Okay? So that proves, I think, the order limit theorems. Okay? Now, they are quite intuitive, pero at least ngayon, settled na tayo. May proof na tayo para sa kanila, and you can use them in your proofs later. Okay? Now, if you don't have any questions, let me move forward. Ba't ang haba? Okay. Teka, baka meron akong... Tinetest ko kung meron akong pinachihan dito. Wala naman, kasi laki ng space. Kasi baka hindi magkakasya yung exercises. So try to answer the exercises. By the way, I just remembered Friday na naman pala bukas. So dapat may homework tayo. Pero gusto niyo ba mag-homework? Pwede ko kayong bigyan ng break next week. All right? Okay lang ba yun? Wag na muna tayo mag-homework para parang prize na rin sa inyo for doing the problem set this past few days. All right? Okay, so I see heart reactions, so I think you want that. All right. Okay, so I'll waive the homework for this week. Pahinga na muna kayo. Pero yung mga nag-175, sila naman yung gagawa ng problem set next week. So, yeah, hindi na lang magbibigay ng homework sa 155. Okay, but please do submit yung reaction paper if you attended yung online event last Monday. Try to write a short reflection paper and submit it before Monday, right before midnight, okay? I'm strict with incentives. Pagka bonus lang naman siya, hindi ako nagbibigay ng extension. Deadline is a deadline, all right? Sayang yung points na makukuha nyo. It's +1 sa problem set. That doesn't sound too much, pero 1/40, that's 2.5%. So magpasa lang kayo, meron kayong plus 2.5%. Ang ating homework ay ilan ba? Ang problem set ay 20%. What is 20% of 2.5? Tama ba? 0.5? Sorry, mahina ako sa math. 0.5 ba? So that's going to be 0.5 in your final grade. So I don't think that's bad. Okay? Tapos dalawang reflection papers nga pala, no? Kasi meron pa tayong event sa Monday. So that's the research webinars. So if you will also submit there, you get +1 again on the problem set. So that's 0.5, I hope, sa final grade. So meron na kayong +1 sa final grade. Tama nga ba compute ko? Sana tama para medyo significant naman yung bonus na binibigay ko. All right. So, yun. Now, let's look at the squeeze theorem. But before that, 28. So that's gonna be bawal. So kung 28 pala yung event, I usually give students 1 week for reflection papers, but 1 week would be will bring us to 28 plus 7, 32. Parang April na yung magiging submission niya, no? Kaya lang tatamaan siya ng reading break. So, plan in ahead, sorry. Plan in advance yung problems, yung reflection paper for the March 28 event will be due on April 1, right before the reading break. Okay? Para hindi ako maakusahan na kinukuha ko yung inyong reading break. I don't think it's hard. So, maiksi lang naman na reflection paper. Or pwede rin naman pala if you want a reflection video or reflection podcast or reflection audio recording para hindi kayo magsusulat. So, pwede naman. Ganun yung i-submit nyo. Alright? So, i-open ko sa Canvas na any file type can be submitted. Kung medyo bida-bida kayo, you want to submit a video. Alright? Link na lang. Link na lang yung i-submit nyo kasi limited yung memory ng Canvas. Parang 500 MB lang yung pwede kong gamitin sa Canvas. So, okay. Oh, I asked a question. Pwede po ba nagpasa ng reflection sa 155? Di na po pwedeng magpasa sa 155. Hindi, yes. So, if you're under me in 155 and 175, then you can avail of the bonus for those two classes. All right? So, treat nyo na magkakaibang tao tayo sa 155 at saka sa 175. Alright? Ibang persona natin yung gumagana sa 175. So, pero pwede nyo kung ano yung pinasa nyo sa 155, yun na rin ang ipasa nyo sa 175. Huwag na tayo maglokohan na gagawa pa kayo ng panibago kasi hindi naman magbabago yung reflection nyo sa 155 at saka 175. Unless dinidiscuss niyo yung topics from a 155 perspective and from a 175 perspective. So in that case, I will appreciate different submissions for the two, but not necessary. So kung anong pinasa nyo sa 155, pwedeng yun na rin sa 175. Mas madali nga yun kasi hindi ko na kailangan basahin yung pinasa nyo sa isang subject. Yun ay kung matatandaan ko yung binasa nyo, right? Pero meron na ako na-encounter na ganun. Parehas yung pinasa sa 155 at 175. Tapos dahil magkasunod ko silang chinekan, natatandaan ko pa na yun na yung pinasa niya sa 155. And that's fine. That's fine. All right. So let's look at the squeeze theorem, which is a very important result. Okay. In lower courses, I think even in math 36, you use the squeeze theorem a lot to either prove limit formulas and as well as to find limits of complicated functions which you can reduce via some order relations. So powerful talaga tong squeeze theorem, but you will see later that the squeeze theorem is also utilized for proving theoretical results. Okay, so hindi lang siya pang computation, pang theoretical din. All right. Now, usually some books, I don't know, sa Pilipinas, usually tinatawag natin siyang squeeze theorem. But when I went in the US and taught there, nung nagsasabi ako, okay, class, remember the squeeze theorem. And all I saw was blank faces. Hindi pala squeeze theorem yung tawag nila. I don't know kung doon lang sa university na yon or in US textbooks, ganun talaga. Ang tawag nila sa squeeze theorem ay pinching theorem. Okay. Pero when I look at different books, squeeze theorem is also used, right? So kay Laytold o sa iba, squeeze theorem yung tawag nila. Pero for some reasons, some students know this as the pinching theorem, okay? Which also basically makes sense. Pero ano ba yung sinasabi ng squeeze theorem? Kapag meron kang tatlong sequences, AN, BN, at saka si CN. Tapos si CN ay nasa sandwich, ayun pa pala yung isang tawag. Aside from squeeze theorem, tinatawag rin siyang sandwich theorem. Okay? Kapag si CN, or bawat term ng CN, ay nasa sandwich nung corresponding terms dun sa sequence ng mga ANs at BNs. So dapat nagmamatch yung mga subscripts. So dapat meron kang si C1 ay bounded below by A1 and bounded above by B1. Ganun din si C2. si C3, and so on. And if that will happen for all n, we can say that the sequence Cn is sandwiched by the sequence An and Bn, or pwede nating sabihin na nai-squeeze ni An at ni Bn si Cn. Alright? So kapag ka daw nangyari yun for all n, and if in addition, An and Bn are both convergent and they converge to the same limit L, then yung sequence na nasa sandwich ay magko-converge din kay L. Madali siya makita sa continuous functions, alright? So halimbawa ito ito yung mga Bn, tapos ito naman yung mga Cn, tapos laging nasa gitna yung ito si An, laging nasa gitna yung Cn, alright? Tapos kapag yung limit daw at a particular point ni Bn at saka ni An ay naging equal sa isa't isa. Ito yung sa real analysis o dun sa function of real variables, alright? Pag yung limit ay naging equal, yung limit ni An at ni Bn ay naging equal sa isa't isa, then equal na rin sa kanila yung limit ni Cn. Alright? Pero sa atin, imagine this to be happening in the long run. Okay? Kasi nga sequence pa lang yung pinag-uusapan natin. Okay? So, this is a nice strategy. Kung nahirapan kang hanapin yung limit ni Cn, kasi komplikado siya, try to think of simpler sequences An and Bn that can sandwich Cn, tapos parehas yung limit ni An at saka ni Bn. Then, if you are successful in finding such An and Bn, then the limit of Cn is automatically equal to the common limit of An and Bn. Okay? Now, I think intuitively that makes sense. Tingnan natin yung proof. Usually kasi yung mga obvious na bagay, sila yung may hirap na i-proof. Okay? Now, in this case, it's not that difficult because it's kind of mechanical. Alright? Kasi nga, ang assumption lang natin dito ay iilan. Totoo tong inequality na to, tapos yung limit nung An at saka Bn ay parehas equal kay L. So, kokonti lang yung wiggle room natin dito. Konti lang yung pwede natin gawin. First of which is look at how this translates insofar as the definition is concerned. Because so far, the only thing we can do with limit statements ay gamitin yung definition. Okay? So alam ko ang limit ng mga Ans ay equal kay L. So that means given an epsilon greater than 0, I can find a starting index n1 such that starting there towards infinity, totoo tong inequality na to, right? An will be very, very close to L. Now, this is, you can write this again as a continued inequality, all right? So, isulat mo yan, An minus L less than epsilon, but greater than negative epsilon, okay? And since, look at our assumption here. Yung isa nating assumption ay inequality involving An, Bn, and Cn. Now, I have an inequality here, pero ang involved si An at saka si L. So perhaps I can isolate An to one side para baka magamit ko siya later dun sa assumption na ito. Okay? So what I'll do is to add L to all sides of this inequality. Kakaroon dyan ng L, magkakaroon dito ng L plus. All right, so what we now know is that An is between L minus epsilon and L plus epsilon. Now, this is a continued inequality, so the connective here is end. So you can apply simplification. Math 101 is waving, so sana tandaan niyo pa yung mga concepts mula doon. Kunin ko lang etong inequality na to. Okay, so here I see that An is larger than L minus epsilon. Now, why did I come up with that idea? Well, kasi si An, siya yung nasa kaliwa ng assumption natin sa inequality, right? Now, hindi ako madaling makakapag-insert dito ng L plus epsilon because all I know is that L plus epsilon is greater than An and An is greater than or An is less than or equal to Cn. Hindi ko alam kung sino yung mas malaki kaysa kay L plus epsilon o kaya kay Cn. So, mahihirapan akong i-insert yung L plus epsilon in this inequality. But that is not the case for L minus epsilon because I know that L minus epsilon is less than An. Dahil less than siya kay An, pwede ko siyang idagdag dito, L minus epsilon sa dulo. Okay? No issues involved. unlike dun sa first case na sinabi ko kanina. And that's what I did here. Ginamit ko yung simplification para para i-reserve yung AN greater than L minus epsilon. And this will happen for all little n's greater than N1. Now, I will do a similar thing para naman dun sa limit ng Bn. Si Bn nagko-converge din kay L. So for the same choice of epsilon greater than 0, I can find a starting index n sub capital 2 such that starting at n sub capital 2, sorry, capital N sub 2, all right, until infinity, yung distance between Bn and L will be less than epsilon. Then I'm going to expand this into a continued inequality and get Bn is greater than L minus epsilon, but less than L plus epsilon. And then I'll do another simplification, but this time I'm going to choose this inequality. Kasi again, madaling i-insert yung Bn less than L plus epsilon dun sa assumption kesa dun sa L minus epsilon less than Bn. Kasi nga, hindi ko naman alam sino yung mas maliit, si Cn ba o si L minus epsilon. So I'm going to choose this. But the problem with these two inequalities ay nagiging totoo lang sila yung una kapag yung little n ay mas malaki na kay N1. Yung pangalawang inequality, nagiging totoo lang siya kapag si little n ay mas malaki kay N2. But I want to combine the two of them into one bigger inequality or a longer continued inequality, but this time isasama ko na si Cn. Right? So I need to guarantee that these two inequalities happen at the same time. And I can guarantee that by choosing capital N to be the larger between N1 and N2. Okay? Because after that capital N, I am sure that these two guys will hold. They will hold at the same time. Okay? At dahil mag-hold sila at the same time, I can write a continued inequality. So since little n is greater than capital N, then we are sure that this is true. Then we also know that at the same time, Bn will be less than L plus epsilon. And by assumption, we know that Cn lies between An and Bn in a continued inequality. So we have this. And then we can simplify this and ultimately say that L minus epsilon is less than or equal to Cn, or actually strictly less than Cn. Kasi meron tong less than. So makikarry yung less than dito. Tapos ito ay magiging less than L plus epsilon then, which is basically can be translated back into something that involves absolute value. I first subtract L from all sides. I'm going to get negative epsilon less than Cn minus L less than epsilon. All right. And then this is the absolute inequality here, which is this one. And then now let's see what we have so far. Now, what we have so far, or some salient parts of the proof, if we give an epsilon greater than 0, however small it is, we can find a capital N, or we know the existence. We are sure of the existence of a capital N, such that right after capital N, or starting at capital N, moving forward, this inequality is true. And that should ring some bells, some celebratory bells. Kasi nakita na natin to. Ito precisely yung definition ng limit. And that is what we exactly want to show here. We want to show that the limit of Cn is equal to L, but we have all the ingredients from the definition. So we can conclude that by definition, the limit of Cn as n approaches infinity is equal to L. End of proof. All right. So yun yung proof ng Squeeze Theorem. Pinrove nyo ba ito sa 30 series? Or hindi na? Kasi intuitive naman yung notion niya, no? So that's why it makes sense. Or probably you have proven it, but the counterpart for the real valued functions. All right. That's okay, David. At least now we know na totoo yung Squeeze Theorem, at least for sequences. Tapos wag niyo tong kalimutan. Kasi di ba later magto-talk pa tayo about mag-uusap pa tayo about functions na ang domain naman ay set of real numbers. So ang gagawin natin, may Squeeze Theorem din doon. Pero yung proof ng squeeze theorem doon, gagamitin natin yung proof ng squeeze theorem or gagamitin natin sa proof yung squeeze theorem for sequences. And that would be the general template for chapter 3. Yung mga limit theorems na alam nyo na from Math 36 na probably pinrove nyo sa Math 36 using first principles. Ipoprove din natin yung ilan sa kanila, pero ang gagamitin natin ay itong mga konsepto na to na na-prove na natin for sequences. And that's why this progression is more natural, I think, kasi mas simple yung sequences. Nag-prove tayo ng mga properties for sequences. Makikita natin later na this will actually imply yung mga properties para sa real valued functions. Okay? Now we have example 2.3 here, which illustrates the use of the squeeze theorem. Though this is not the highlight of the squeeze theorem for this course, kasi nga hindi tayo on the computational side. We are more on the theoretical side, but it won't hurt to look at some computations from time to time. So for instance, you're asked to find the limit of this complicated expression over here, all right? But again, ito yung sinasabi ko kanina. Posibleng mabigyan tayo ng mga komplikadong sequences. Kung ganun yung nangyayari, pwede tayong maghanap ng dalawang sequences na magsa-sandwich dito sa sequence na to and hope na yung dalawang sequences na yun parehas ng limit. Kasi pag nagkataon na totoo yun, yung limit nito ay equal dun sa common limit yung dalawang sequences. So we'll take a quick look at this guy. All right. Now first, striking yung cosine. Yan yung una yung titingnan, yung mga trigonometric, especially sine and cosine. Kasi alam natin ang cosine at sine ng kahit anong expression o kahit anong function ay laging less than 1 or less than or equal to 1. So this complicated guy over here has absolute value less than or equal to 1. So mas simple na siya. Tapos tingnan nyo yung 2 to the negative n. Now we know that 2 to the power n ay laging mas malaki kay capital N. Like when n equals 1, we know that 2 is greater than 1. When n is equal to 2, you have 4 greater than 2 and so on. So mas mabilis lumaki talaga yung 2 to the n, all right? Actually, for all natural numbers, totoo yung inequality na yan, right? And then just divide both sides by n times 2 to the power n, you will end up with this guy. So basically, what we now have here is this, okay? Yung expression natin kanina ay laging mas maliit or equal kay negative 2 to the negative 2n at saka kay 2 to the minus n. Tama nga ba yan? Yeah, because this guy, yung cosine, ay between negative 1 and 1. So probably you can start there. So yung cosine ng n cubed minus n squared plus n minus 13 ay strictly between negative 1 and 1. But negative 1. Damn it. So ito ay negative 1 and 1. Alright? Tapos mag-multiply tayo ng 2 to the power n, 2 to the power negative n to both sides. So ito ay magkakaroon ako ng 2 to the minus n. So ito ay magiging negative 2 to the minus n. Tapos ito ay magiging 2 to the minus n. Tapos, napakita natin kanina na yung 2 to the negative n ay mas maliit. Ito. So 1 over n. So that guy is there. And then here, ito ay mas maliit sa negative 1 over n. You just multiply both sides by negative 1. Okay? So now we have the original term in the sequence. The term in the original sequence. Nakita na natin na siya ay mas malaki sa negative 1 over n, pero mas maliit sa 1 over n. So nasa sandwich ni negative 1 over n at saka ni 1 over n yung n term ng sequence natin. Okay? And then luckily, the limit of this guy and this guy are both equal to 0. Na-prove na yata natin to last time na ang limit ng 1 over n as n approaches infinity ay 0. So dahil nasa sandwich nito at nito yung sequence na nabigay, tapos parehas yung limit ng nasa kaliwa at ng nasa kanan, so dapat mag-agree na rin yung limit ng nasa gitna. So therefore, the given sequence converges to 0 by the squeeze theorem. Okay. The only challenge in the squeeze theorem is to find that sequence AN and BN. Yan yung medyo mahirap isipin. Okay? So, try this one, this exercises. Actually, tinry ko itong pag-isipan kanina. Hindi ko mahanap yung sequence para kay para kay n raised to the 1 over n. So, kindly try this one, guys. Share nyo sa akin next time kung ano yung sequence AN at BN na pipiliin nyo kay n to the 1 over n. So, ano yung dalawang sequences na magsa-sandwich kay n to the power 1 over n? And since the exercise is telling us or is asking us to prove this using the squeeze theorem, so probably kailangan ko maghanap ng dalawang sequences na parehas nagko-converge kay 1 na magsa-sandwich kay n to the power 1 over n. I might be missing something pero hindi ko siya maisip kanina ng mabilis habang nagkakape ako. So hopefully you guys can think about that. Okay. Alright, so think about that. Yun sana yung papa-homework ko pero wag na nga lang muna tayo mag-homework. Okay. Now, sequences, yun yung mga elementary properties ng sequences. Now, tingnan naman natin yung tinatawag nating mga subsequences. Now, as the name implies, yung subsequence ay parang subset ng original sequence natin. Actually, subset siya talaga in the set theoretic sense, okay? Kaya lang, 'di ba ang sequences natin ay ordered list. So yung subsequence ay isang sequence na ma-form mo mula sa isang parent sequence such that yung mga terms dun sa subsequence ay nanggagaling dun sa parent sequence with only one condition. Dapat na-preserve yung order. Okay? So halimbawa, how do I make sense of that? Parang nakagulo pa yung layman's interpretation ko, no? Pero parang ganito yan. Meron kang sequence A yan. A1, A2, A3, A4, A5, and so on. So ito yung sequence. Or that's the original sequence. Yung subsequence ay isa pa ring sequence. Pero yung sequence na to, kaya sub, ay manggagaling dun sa original sequence na kinoconsider natin. The only restriction is na preserve sort of yung order ng terms. So ang gagawin ko lang, pipili lang ako ng mga terms na nanggagaling dun sa sequence kanina. So halimbawa, sige, piliin ko si A1. Bababa siya doon. Tapos, ang susunod kong pipilian sa kanya ay si A3. Kaya siya sub. Kasi hindi ko kailangan piliin lahat nung nandun sa original sequence. Pero para maging subsequence siya, dapat ma-preserve ko yung order. Halimbawa, piliin ko si A5 to be yung susunod na term. Now, hindi ko na pwedeng piliin si A4 kasi I'm always moving forward. Pagka na-etsapwera na kita at pinili ko na yung masusunod sa'yo, wala nang chance na mapili ka pa. Alright? Kasi yun yung idea o yun yung sense na na-preserve yung order ng sequence doon sa subsequence. So that means I cannot write A4 over here because that means the resulting sequence is not a subsequence of the original sequence anymore. Kasi ang usapan dapat na preserve ito. So if I say I choose here A sub 100, wala nang mga subscript pa na mas maliit kay 100 na mapapasama dun sa subsequence. Okay? And then to emphasize the relation between the sequence and its subsequence, all right? Usually ang labeling natin dito ay A sub n1, ito ay A sub n2, ito ay A sub n3, ito ay A sub n4. Okay? Mas dumarami yung subscript doon sa ating sequence, all right? So ibig sabihin, ito yung first term doon sa subsequence. So rito ang n1 natin ay equal kay 1. Si n1 siya yung first index doon sa ating bagong subsequence. So n1 is equal to 1 and then n2 is equal to 3 because 3 is the second index in the subsequence. Right? And then n3 is equal to 5 because 5 is the third index in our subsequence. Okay? So that means we can say that n sub k is always greater than or equal to k. So yung kth index doon sa subsequence ay laging mas malaki dun sa kth index, ay laging mas malaki or equal dun sa kth index dun sa original sequence, right? Kasi yung A1, pwede siyang C1, 2, 3, 4, and so on. Okay? Pero si N2, hindi na siya pwedeng maging equal kay 1. Pwede pa rin ba siya maging equal kay 1? Kasi dapat mas malaki. Yeah, ito ay hindi na pwede maging equal kay 1. Kasi yung second term o yung second index dito ay hindi pwedeng maging equal kay 1. Kasi if that is the case, then si A1 kasi dapat siya yung nauuna. Alright, hindi siya pwedeng maging pangalawang term dun sa sequence. Hindi pwedeng maging A1 to so that N2 is equal to 1. That's impossible because A1 should always be the first. Okay? In the same manner that N3 cannot be equal to 2 because N3 means siya yung pangatlong index dun sa subsequence. Pero si 2, hindi siya pwedeng yung maging pangatlong index kasi siya nga yung pangalawang index dun sa original sequence. And na-preserve yung order. So si 2, hindi siya pwedeng maging third index doon sa dun sa subsequence. Alright? Kasi nga dapat increasing yung mga n sabays. Dapat mas malaki sila lagi or at least equal kay k. Alright? So I hope that's clear. Pero mukhang pinakomplikado ko pa yung notion ng subsequence niya. Pero ganun yung idea ng subsequence. Dapat in order mo pa rin sila pinipili. Once naligtangan na, hindi na siya pwedeng mapili ulit. Okay? So some examples of subsequences. Pwede mong kunin lamang yung subsequence consisting of odd subscripts. So A1, A3, A5, A7, and A11. So ito yung mga A sub 2K plus 1. Okay? Or pwede mo rin naman kolektahin lahat lang ng merong even subscript. Alright? So sila ay subsequences pa rin kasi tingnan nyo yung subscripts. Yung subscripts ay in increasing order pa rin. Nauna pa rin si A2, sumunod si A4, sumunod si A6, sumunod si A8, and so on. So this guy is a subsequence of AN. Pero if it happens that you have, say, an A7 here, hindi na siya subsequence ni AN. Kasi nabago yung order. Nauna si A8 kaysa kay A7. Okay? Now, in the alternating sequence that we have seen before, makikita ko na meron siyang dalawang constant subsequences. Pag kinuha ko lahat lamang ng may lahat ng may odd subscripts, alright? Pag kinuha ko si A1, A3, A5, A7, and so on, I'm gonna get the sequence consisting of all negative ones. Tapos, pag kinuha ko naman lahat ng even subscripts, I will form the constant sequence ones. So, itong dalawang ito ay subsequences ni AN. Okay? And then, kapag ka ito naman yung sequence, ang sequence may 1 over n, ito ay isang subsequence din. Kasi si 1/2 siya yung second term dun sa original sequence, si 1/4 siya yung fourth term, si 1/6 siya yung sixth term, si 1/8 siya yung eighth term, and so on. So, increasing order pa rin siya of subscript. And then 1, 1 over 10, 1 over 100, 1 over 1,000 is another subsequence of that sequence. Alright? Pero, etong last na to ay hindi siya subsequence. Bakit hindi siya subsequence? Kasi si A over 10, siya yung pang-10 term dun sa original sequence. And yet, it is followed by 1 over 5, which is the 5th term in the original sequence. So, hindi na preserve yung order, hindi siya subsequence. Okay? Now, it's quite interesting to see na eto, yung parent sequence na -1 to the power n, nakita na natin na yan ay divergent. Okay, na-prove natin na imposible ang mag-converge. And yet, look at these two subsequences. Etong dalawang subsequences na to ay convergent. So, posible pala na pag merong kang divergent sequence, posible pa rin siyang magkaroon ng at least isang convergent subsequence. And that's just by smartly choosing the elements of the subsequence. So you can do it on purpose, posible pala tayo makakita. Later, we will see a result kung kailan nangyayari yon. Hindi to mangyayari sa lahat ng divergent sequences, alright? Pero titingnan natin ano yung property na kailangan para yung isang sequence laging magkaroon ng convergent subsequence. Alright? If you're beginning with a convergent sequence, then it is trivial na lagi siyang may convergent subsequence. So sige nga, kung meron akong convergent sequence, can you guys give me a convergent subsequence? So halimbawa, meron akong convergent sequence na AN. Now, can you guys give me a convergent subsequence ng AN? Sige, habang pag-isipan nyo, health break muna tayo. 2-minute break. Think about it. And then after 2 minutes at 12:33, I'll ask for some volunteers, all right? Grabe, super init, no?
Parang Texas po ba, sir?
Mas gusto ko ang summer doon kesa dito. I mean, yeah. Feeling ko mas bearable ang summer doon. Hindi kasi siya, ano bang tawagan? Tama ba? Humid ba yung summer natin? Hindi ko alam
Yes
kung,
po.
yeah, yung parang pagpapawisan ka talaga, no? Sa Texas, alam mong mainit, pero hindi ka pinagpapawisan. Hindi ko ma-explain, pero yun nga. Pwede kang maglakad sa park and so on. Ramdam mo yung init, parang nasa loob mo yung init, pero hindi ka pinagpapawisan. I mean, hindi siya mas maganda physiologically, pero parang from a comfort point of view, parang mas okay siya kasi hindi yung jahing na naiinitan ka. Ang isa pa
Ganun din,
siguro
sir.
dahilan kung bakit ay usual kasing naka-aircon ng mga taga-Texas. So, usual na sa kanila na, common sa kanila na nakabukas ang aircon maghapon. Eh sa Pilipinas, parang hindi sa atin, ang hirap magbukas ng aircon maghapon kasi patay ka sa electric bills. Yes, David, I think, I thought you're about to say something.
Ang so based sa kwento niya, sir, parang ganun din sa bandang Middle East sa mga naririnig ko po sa friends ko. It's dry, it's hot, but it's not like here na humid po.
Yeah.
Nakaka-dry lang daw ng skin doon, pero dito talaga yung pawis.
At least hindi tayo na-dry ang skin, ano. Pero doon, yeah, kaya pag mga ganitong panahon doon ay babad ako sa office. Para makatipid ng aircon sa apartment. Papasok na lang ako sa opisina para doon ako maghapon. Kahit naka-work from home nun. Kahit nung pandemic doon hindi kasi ako makatrabaho ng maayos sa bahay. Kasi pag nasa bahay o nasa apartment, ang daming temptations. Nandyan yung kama, nandyan yung Netflix, pwede kang magluto, pwede kang mag-bake. Medyo, na-addict din ako for some time sa pagbe-bake. So, ano pa ba mga pinagagawa ko nun? Basta marami akong inisip na gawin nun. So, kahit nung nag-pandemic at nag-lockdown sila, nag-apply ako ng permit sa university. Kahit nung kasagsagan, March 2020, nag-apply talaga ako sa university ng permit na payagan niyo akong pumasok ng opisina. Kasi wala akong matatrabaho pag sa bahay. So to a point na kailangan ko pang kumuha ng keycard, magpa-validate sa university police para makapasok dun sa building, sa math building nila doon. Tapos para hindi ako sitahin nung office managers, ganyan-ganyan. Pero hindi ko alam, dito ay parang ayokong pumunta ng office. Ayokong bumalik muna ng math building. Pero tinry ko yon nung August, bago mag-second ECQ. At least once or twice a week, nagpupunta ako math building. Pero ang gastos pala dito. hindi ko ma-consent, ano ba, hindi ko tanggap na magla-lunch ako sa labas na ganun kamahal. I don't know if that makes sense, pero
Sir, kumusta na po yung tinatayo na math building sa likod ng kahoy na math building?
Ongoing pa rin yung construction, pero I think it's malaki na yung progress. I think couple of floors are done already. Tapos yung flooring niya okay na rin. Though pinag-iisipan pa kung ipapa-tiles or hindi. Luckily, madaling humanap. May mga pondo na, alright? May mga pondo na nahanap, so procurement na lang. Tapos hopefully maayos na yung contractor matapos na siya talaga. Actually, the story of that build, excited na ba kayong lumipat sa building na yon? Kasi kami excited na. Unang lumabas yung plano niyan, alam niyo ba ay third year college pa ako. So, junior, ang saya, naka-post dun sa pagtaas mo ng second floor ng math building, malaking billboard, naka-post soon to rise. Ganyan. Junior ako noon, undergrad. So sabi ko, pag nagturo ako dito, siguro first year of office ko, tama-tama, bago na yung building, aircon na lahat, and so on. Ganyan. Tapos, hanggang ngayon, nakabalik na ako, nakapag-masters na ako, nakapag-PhD na ako. Andun pa rin kami sa lumang building. Kakatawa nga eh. There was even a Christmas party. Sa faculty na ako, there was a Christmas party ng exchange gift namin ay ang team ay something that you will bring to the new math building. Tapos after more than 5 years, so siguro mga 7 or 9 years na wala na yung exchange gift namin, di pa kami nakakalipat sa bagong math building, right? Million. Pero dahil hindi siya natapos nung unang contractor, inflation kicked in, hindi nakasya yung budget. So kailangan humingi uli ng budget kung kani-kanino para mapunan yung kulang and so on. So a lot of problems there. But hopefully, siguro conservative estimate na yung 1 year. Hopefully in 1 year, ang target nga namin pag face-to-face, sana doon na tayo magkita-kita eh. So hopefully sabi ko sana hopefully wag muna kayong graduate. Hindi. Hopefully bago kayo graduate, makalipat na tayo ron. Alright? So, okay. Napahaba yung break, yung kwentuhan, but that's fine. So, ayun, nakaisip ba kayo ng pag meron kang convergence sequence, can you give me an example of a convergent subsequence? Pwedeng generic example o pwedeng specific example?
Sir, pag 1 over n, nagko-converge ata siya sa 0.
Yes. Okay.
So we could just take like 1 over n sub 2k. Same pa rin naman atang order.
All right, so that's good. Yeah, that's right, David. So pwedeng yung mga even yung subscript, no? So ibig sabihin 1/2, 1/4, 1/6, 1/8, and so on. Yun yung subsequence mo na convergent. Okay, that's right. Thank you, David. Actually, it's quite trivial in a sense that pag meron kang convergent sequence, kapag ka meron kang sequence, yung sarili niya, subsequence niya rin. Right? So kung meron kang convergent sequence, di kunin mo lang siya as sarili niyang subsequence. Convergent pa rin yun. Right? So that's one quick example. But thank you, David, for the specific example. Now, this is basically what I'm saying kanina. Actually, kapag ka meron ka nga palang isang convergent sequence, kumuha ka ng kahit anong subsequence niya. Literally, any subsequence, magko-converge pa rin yon, and it will converge to the same limit as what we will see in Theorem 2.6. Okay? Now, tingnan natin ano yung sinasabi ng Theorem 2.6. It relates the convergence of a sequence with the convergence of some of its subsequences. All right? Because this is telling us that the following 3 statements are equivalent. Statement 1, si AN ay nagko-converge kay A. Equivalent daw yon sa pagsasabi na lahat ng subsequence ni AN ay nagko-converge din kay A. So pag nag-start ka pala sa isang convergent sequence, pag kumuha ka ng kahit anong subsequence, magko-converge pa rin yon, and not just that, magko-converge siya dun sa kaparehas na number kung saan nagko-converge yung original sequence. Which makes sense kasi remember, ang ginagawa lang naman natin sa subsequence, kinukuha lang natin yung mga elements ng original sequence and we keep the same order. So as we go along, nandun ka sa dulo ng listahan, yung mga candidates mo to be in the subsequence ay palapit ng palapit dun sa limit na A kasi ang assumption mo nagko-conversion kay A. So habang nasa dulo ka ng listahan, palapit ka ng palapit kay A, so yung mga candidates na napapasama dun sa subsequence ay palapit din ng palapit kay A. So it makes sense intuitively, even a layman can understand it, na okay, pag ganun mo pinipili yung subsequence, edi dapat parehas lang yung limit ng sequence at saka ng subsequence. And true enough, yun yung ipoprove natin sa Theorem 2.6. Okay. And then statement letter C is, I think, a special case of statement B. All right. Na pag kinuha mo yung sequence, yung subsequence consisting of even subscripts and odd subscripts, parehas sila magko-converge kay A. Now, this is an equivalence theorem. So, ibig sabihin, meron tayong tatlong statements. So, dapat yung isa mapuprove natin from anyone and vice versa. So, in this particular case, theoretically, we need to prove 3 biconditionals. A if and only if B, B if and only if C, and C if and only if A. But we can take advantage of hypothetical syllogism. Again, Math 101 is waiving, na pwede natin gawin ganito yung proof. Pakita natin na A implies B, tapos pakita natin na B implies C, then pakita natin na C implies A. So in this particular case, we know that B still implies A, kasi B implying C, C implying A, by hypothetical syllogism, B will imply A. So napakita pa rin natin na equivalent si A at saka si B, right? And so on. So basically, instead of proving 3 biconditional statements, which is equivalent to proving 6 conditional statements, we can reduce the number of proofs we need to write to 3. Ipoprove lang natin yung tatlong conditional statements. A implying B, B implying C, and C implying A. Right? Now let's do that. Let's start with A implying B. Now, if we want to prove that A implies B, so we need to start with a convergent sequence and then show that any subsequence will also converge to A. Right? So yun yung ginawa ni lecture notes dito. Okay? So ang assumption, si AN ay convergent papunta kay A. Now, definition of convergence. So for every epsilon greater than 0, we can find a starting index such that after that starting index, this inequality is true. Okay, now, ginamit lang yung definition. Pero dun sa remark natin kanina, alright, alam natin na n sub k ay laging mas malaki or equal kay k. Ibig sabihin yung k subscript doon sa subsequence ay dapat mas malaki or equal dun sa k subscript dun sa original sequence. Alright? So, if I will choose little k to be larger than the starting index, then we will have discontinued inequality. Alam na natin to ay totoo from our observation earlier, and I think it was written as remark 2.4 in the lecture notes. So we already seen this. And if we will put the additional assumption that little k is greater than n, then we will have this continued inequality. All right. But if this is true, then n sub little k will be greater than the starting index capital N. Dahil si n little k ay mas malaki dun sa starting index n, therefore the distance of the n sub the distance between the k term in the subsequence, yung a sub nk, mula kay a ay mas maliit na sa epsilon. Kasi si n sub k ay magkwa-qualify as one of the little n's for which this inequality is true. Alright? Kasi halimbawa, ito yung starting index capital N, nandito si, pinili natin si capital N, si little k ay nandyan by our additional assumption. Pero alam natin yung n sub little k dapat mas malaki yan dapat kay k. So ibig sabihin si n sub little k ay lampas na dun sa starting index. So ibig sabihin itong inequality na to ay mag-hold para kay n sub little k. So that means this must be true. Okay? But if again you will review what we have done here, we have shown that for every epsilon greater than 0, there exists a starting index capital N such that for all little n sub little k's that are greater than n, then this inequality is true. And that is the very definition of the convergence of a sub n k to the real number a. And so we have proven that indeed the subsequence will converge, and not just that, it will converge to the same number a. All right? So done, A implying B. Now let's write B implying C, but the handout says that's kind of obvious, all right? Ano ba yung assumption sa B implying C? Ang assumption natin ay kunwari, lahat ng subsequence ay nagko-converge kay A. That's our assumption in the second proof that we are writing. But what do we want to show? We want to show that the subsequence consisting of even and odd subscripts respectively will also converge to the number A. Pero trivial ngayon kasi ito ay subsequence, by assumption lahat ng subsequence ay nagko-converge. So therefore, magko-converge din sila sa A by virtue of being subsequences. So B implying C is an obvious matter. Okay? Now, medyo mas challenging yung baliktad to. Ito ay C implying A. Note ko lang para sa next revision. Okay? Okay. So, A implying C. C implying A. So C implying A, i-assume natin na nagko-converge yung odd saka yung subsequence consisting of odd and even subscripts. Pareha sila nagko-converge kay A. So gusto kong ipakita na pag nangyari yon, magko-converge din si AN doon kay A. Alright? Alright, so let's see. Now, gagamitin ko yung definition ng convergence kasi ang i-assume natin itong dalawang subsequences na yan ay nagko-converge kay A, ang mga subsequences ay sequences din naman. So, yun yung gagamitin ko yung definition. So, itong dalawang inequalities na to will be true, right? There will be a starting index after which totoo tong inequality na to, and then another starting index such that after that starting index, this inequality will be true. All right? Now, gusto ko ipakita na si AN ay magko-converge kay epsilon. Magko-converge kay A. Now, here's a little trick. Okay? So again, piliin ko, parang usual na natin to, no? Pinipili natin si capital N to be the larger between the two subscripts. Okay? Kasi ito ay nagiging totoo simula kay 2 subcapital N. Alright? Or 2 subcapital N1. Ito nagiging totoo starting kay A sub 2n minus 1. All right. So if I will choose n to be the larger between these two initial numbers, all right, then I am sure that for any n after this guy, totoo na tong inequality na to. Bakit? Kasi halimbawa ito si 2n, ito si 2n minus 1 ay nandito pala sa 2n sub 1. Ito ay 2 sub n2 at 2 times n sub 2 minus 1. Alright? Pag pinili ko si n to be the larger among them, halimbawa ito yon. So ibig sabihin, ito na yung kinoconsider ko ng mga little n's. Okay? But there are only two possibilities for little n. Little n can either be odd or even. Kung ito ay odd, okay, lampas na siya sa 2 sub 2n minus 1. Okay? So, ibig sabihin, magiging totoo na tong inequality na to. Kung si n ay even, si n ay lampas na sa 2n, sa 2 sub n minus, sa 2, sorry, nahihirapan ang magitin yung subscript. So, kung si n ay even, by the choice of capital N, si little n na even ay lampas na sa 2 times n sub 1. Dahil lampas na si n kay 2 sub n minus 1, etong inequality na to ay magiging totoo kay a sub n. And napakita na rin natin na yun din yung nangyayari kay odd. So, mapa-odd or even si little n, etong equation na to ay totoo. Alright? And again, that is the very definition of the limit. Because here, we have an epsilon greater than 0. We have found the capital N, such that right after capital N, this inequality is true. So the sequence AN converges to A. Alright? So yun pala yun. Kapag meron kang isang sequence, tapos kinuha mo yung sequence na puro odd at puro even, nag-converge sila parehas kay A, automatic yung sequence magko-converge na rin kay little a. So pwede mo siyang gawing shortcut kung meron ka isang komplikadong sequence. Alright? Tapos mahirap siyang hanapan ng general formula or hanapin yung limit ng general formula, pwedeng tingnan mo yung mga odd sequences. Yung odd subsequence, tapos tingnan mo yung even subsequence. Pag yung dalawang subsequences na yun ay nag-converge sa parehas na number, then by this theorem, we are sure na magko-converge na yung parent sequence to the same number. Okay? And then another way is, kaya lang medyo mas mabigat yung other way. Kailangan lahat muna ng subsequence mapakita mo na nagko-converge kay A para makonclude mo na si A ay nagko-converge kay A. Which is mas mahirap kasi kailangan ipakita every subsequence. Unlike a part C na kailangan mo lang ng dalawang subsequence. Yung subsequence ng mga even at subsequence ng mga odd. Alright? Now we will end with the divergence criterion. Now, what does the divergence criterion tells us? Now, this is an easier way to show that a sequence is divergent, okay? Now, and it directly follows from Theorem 2.6. Kasi sa Theorem 2.6, sabi natin kapag ka si AN ay magko-converge kay A if and only if lahat ng subsequences ay nagko-converge kay A. Alright? So that means I can take half of this biconditional. Pwedeng kunin ko tong conditional to, yung A implying B. Kapag yung parent sequence ay nag-converge kay A, lahat ng subsequences ay magko-converge din kay A. Now, I will take the contrapositive of it. Kunin ko yung contrapositive. Ang contrapositive niya ay, instead na for all, if there exists a subsequence that does not converge to A, then the parent sequence will not converge to A either. Okay? Or in a more general sense, if you can find a divergent subsequence, okay, then, wala ka pala mawawang conclusion doon, no? Sorry. Mali yung iniisip ko. Masyado palang specific yung contrapositive na naisip ko. Pero totoo yan. Kapag meron kang isang sequence, isang subsequence na hindi nagko-converge kay A, then the parent sequence will not converge to A. Okay? And a little corollary to this, siguro a couple more steps from that contrapositive is, pag nakakita ka ng dalawang subsequences na nagko-converge sa magkaibang limit, then automatically the original sequence diverges. Yun yung sinasabi ng divergence criterion. So if you will be able to devise two subsequences na parehas convergent, pero magkaiba yung limit, then the sequence diverges. But it is not true that you only need to find two subsequences na nagko-converge sa parehas na limit para makonclude na yung original limit ay nagko-converge din. Okay? So an illustration of this ay para dun sa alternating sequence. So dun sa alternating sequence sa -1 to the power n, pag kinuha natin lahat ng, pag binuo natin yung odd subsequence or the subsequence formed by odd subscripts, magko-converge to kay -1. Pero yung even subsequence naman, magko-converge kay +1. Here we have seen two subsequences that converge to two different values. So by the divergence criterion, the original sequence will not converge. Okay? So I think we can end here. So tandaan nyo, ito yung madaling paraan ng pagpapakita ng divergence. Okay? In the succeeding lectures, we will start talking about the big names or the big theorems in sequences. And they are big specifically because they are equivalent to the completeness action. All right? Any questions? All right, so if there are no questions, then thank you guys for coming today. Just watch out for the results of the problem set. From time to time, I am grading things. So tingnan nyo na lang kay Canvas kung may updates na sa score nyo. Again, dun sa balikan nyo na yung true or false kung you're curious about why you got a wrong mark for one particular item. May explanation ako doon. Basahin nyo na lang. Wag nyo lang i-share sa iba kasi or sa social media kasi meron pa mga hindi nakakatapos ng problem set. All right? So enjoy the weekend, guys. Keep safe, and let's see each other again on Tuesday. Bye, everyone.
Thank you po, sir.
Okay, you're welcome.